Okay, the next thing which I want to talk about is categorical versus categorical. For that, we use chi-square. Okay, so it's like the for different relation, you have to see the different statistical measures to find the correlation between them, whether one is dependent on each other, whether one relationship is explained by another, like one and both variable is explaining each other, one is increasing, so the other will also increase. So in this case, what I was talking about in this case, like if male or female and scientific grant, yes or no. So if someone is male, so whether his chance of getting accepted, his scientific journal, the chance of being accepted is more or no, or like it is dependent on that. So then it will be yes or it will be no, like that. So if like someone is male, so maybe probability of getting scientific journal accepted is more or not, or it is less. So that will be actually explained by this chi-squared. All right, and this chi-square, the formula is here, this is chi-square value, and the formula is observed score minus expected score, a whole square, and then we divide it by expectation, and then we sum it up. So this formula will be more clear when I will give the example. So in this example, I'm taking gender. In this case, gender is male and female, yes and no. So how many male? So here, male whose scientific journal was accepted is 100, the actual value it is, and the female, the accepted scientific journal is 40, no is 600, and here for female the no is 5. All right. So here, what I'm doing, the simple thing, how you calculate, I have taken the sum here, 100 plus 600. That is how many males are there. That is 700 male total. Female, we have 540. And how many actually got selected? That is 140. And no is 110. 110 journals was not accepted. Total is coming out to be 1240. All right. So these are these 140, 600, and 500 are observed value. Now the in formula we have one observed value here, and the next one is expected value. So how we calculate expected value? So there will be expected value for each these cells. So this is E11, E12, E21, E22. So E11, how we'll calculate the first expected value for this? So what expected value is? So this is actually observed value. So based on statistics, what should be the expected value? Expected value we calculate as 140, this total, how many yes is there, into how many males are there, into 700, divided by total, that is 1240. What it will give me? It will give me like how many male and yes, based on statistics, what should be the expected number, and that expected number is coming out to be 79. Similarly, E12 means female and uh, then yes, the expected value I'm getting is 61. All right, that expected value I'm getting is 61. It means like it should be, by statistics it should be around 61. Similarly, E21 I've calculated, that will come out with 621. E22, that is like female not selected, that should be 479. Then in chi-square I have done the null hypothesis, and this hypothesis I have done, that is like gender and grant is independent. That is my null hypothesis. There is no relationship between gender and grant. Okay, then next step is to calculate the chi-square. For chi-square, what I do the observed minus expected. So observed here is 100, minus I'll do by expected E11, that is 79 whole square divided by 79. Then sum, then again observed, this is observed, this value, all right, minus 61 whole square divided by 61 plus 600 minus this same thing is being repeated, and you will get the value of 14.62. So here again, it is not like the Pearson coefficient or Spearman rank coefficient which you were getting earlier. This is a chi-square. This is a different value. This you will not think that it will range from -1 to 1. All right. For checking the relationship, there is a different method for it, and the method is this. Like I have got this chi-square value as 14.62. Next thing what you have to calculate is degree of freedom. All right. For degree of freedom, how we calculate? Like I will do r minus 1 into c minus 1. So what is r? R is number of rows. So here I have two rows. This one, two rows. So I'm doing 2 minus 1. Then I have two columns here. There's two columns, 2 minus 1, and we multiply it out. So after multiplying, it is 1 minus 1. So I'm getting as 1. All right. So two things I have got, that is chi-square value and degree of freedom. Okay. Now these, using these two, I will get what is the probability. Like if I have done the null hypothesis that these both are independent. Okay, and then if the probability of both being independent, I am getting as high as 0.756 or zero point 0.6 or even 0.2, 20% probability, then I'll say okay, this is like high probability and both are like independent. All right. And if I get very less probability, kind of like 0.01, 0.05 kind of thing, then we can say, all right, this is like very less, and both are not independent. That depends on each other. So how we do that? So for saying that, we have to look at the chi-square table. Okay. So we look at chi-square table. Chi-square table I will open just here. Uh, chi-square table. Let me open it. Okay. So here you can see we have degree of freedom, different degrees of freedom, and you have these chi-square values. So 2.71, 3.84, 5.02. These are chi-square value, and what this is, this tell you the p-value, the probability value. So in our case, if you go back to our presentation, there we had the correlation, chi-square value as 14.62 and degree of freedom as 1. So I will go here, degree of freedom as 1 and 14.62. So it will be higher than 6.63. We don't have that number here, but we can we can just imagine this. Okay, that p value will be actually smaller than 0.01, right? Because you can see as this value grows, our probability also, probability as this value grows, chi-square value grows, our probability comes down. All right, so it will be less than 0.01, you can say, because our value is 14, and here the last value is 6.63. So it will be less than 0.01. Okay, the probability is less than 0.01. Okay. So means the probability is very less for grant and gender to be independent, right? It is very less. If that probability would come around this, then we would say that both are not related, but here the probability is very less both to be independent. So we will say both are dependent on each other. So that is how we do for categorical versus categorical relationship. Okay. So now I hope this is clear. If you have any doubt, you can ask us on chat, or you can ask us on mail. All right. The next, which I want to talk about, the last point is this correlation which we are talking about does not imply causation. What this mean actually? It means like you are saying, if I got in case of let us say in case of height versus salary, I am saying based on data that okay, this height and salary is correlated, but that doesn't mean that your salary is basically, the higher salary is caused by a height. That is a fallacy here. We see that based on data, the relationship is coming. That relation is coming, but there might be some other factors that is driving that. Height is just based on data that has come down, that has came here randomly, but that doesn't mean that correlation is high. That means the response value is caused by explanatory variable. That is the thing, that this is a very important concept to think about, or keep that in mind, that correlation does not imply causation. All right, so thank you all.
Audio Jungle.